Alright guys, so I just wanted to quickly take you through how to describe the motion of a charged particle in a magnetic field. This will be pretty quick and sweet because you've seen a lot of it before. So first of all, looking at this picture here, as a particle is traveling perpendicular to the magnetic field in this picture, we'll see that the force at any place is going to be pointed towards the center of a circle. So in this case, the force of the magnetic field is acting as the centripetal force on the charged particle. These X's again indicate that the magnetic field is going into the screen, and we have a positive charge going to the right down here. So if you use the right hand rule correctly, you should see that the force is going up. Make sure you get that straight. And then over here, you're using the right hand rule again. You should see that the force is coming in, and in fact any place around the circle you should be able to use the right hand rule and see that the force is pointing towards the center of the circle. So going back to our equation for the force on a charge in a magnetic field, F equals QVB sine theta, and also realizing this is going to act as a centripetal force, and therefore it has to obey the relationship, or the motion has to obey the relationship mv squared over r, where r is the radius of the circle here. And setting these two equations equal to each other, we can get an equation for the radius of the circle that a charged particle will travel in. That radius will be equal to the mass of the charged particle times its velocity divided by the charge in coulombs times the strength of the magnetic field in Tesla. So using this equation, which we derived again from the centripetal force equation and from the expression we have for the magnetic field, we can calculate the radius of curvature, the radius of the circle that the charged particle will travel in, and that will help us describe the motion of this particle as it travels through a magnetic field.